Okay, time for another video. Welcome back. Thank you for watching. Today I'm going to talk about what is called Pythagorean tuning. Pythagoras was a Greek philosopher. He lived about 2,500 years ago. And he was not only a philosopher, he was an overall scientist, an explorer of life, you could say. He's also often referred to as the father of modern music. And he's also credited for the idea of the music of the spheres. The idea that all the planets in our cosmos, they emit sound, and these sounds sort of play a harmony as they go around. This makes perfect sense to me, of course, as the entire creation is basically based in harmony and the perfect geometry, sacred geometry, if you will. Pythagoras also invented, or maybe we could say discovered, a tuning system that is still in use today and very famous and very popular. It is called, as you probably guessed, Pythagorean Tuning, and it is based on perfect fifth ratios. The perfect fifth is the most harmonious interval in music besides the octave. And how this works, say, if we start with a root frequency of 432 Hertz, we simply take 432 times 1.5, and then we get 648, which is the perfect fifth of 432. Then it goes on, then it takes 648 times 1.5, and you get the result of that, whatever that is. Never mind, it's not important. And then, once again, the perfect fifth of 648, you take that times 1.5, and so on and so on and so on until you get through the whole scale. The thing about Pythagorean tuning is when you use this system for a 12-tone scale, you encounter a problem. When you get to the 12th note, which is, or the 13th rather, which is the octave of 432, that should be 864. But with Pythagorean tuning, that becomes 875.7877807617. And this isn't because Pythagoras was wrong, it's simply because he didn't use a 12-tone scale. Pythagoras probably only played what is called tetrachords, which only has 4 notes. The 12-tone scale is a more recent discovery or invention. But later on, people discovered how to use Pythagorean tuning for a 12-tone scale, and we're going to have a little look at some of the intervals right now. Before we get into this, it's one thing that's very important to know about 432 tuning and the what I call the magic frequencies or the sacred frequencies. It's that there is no scale where all the magic frequencies are represented. That wouldn't be harmonious. You start with a root frequency, you pick your root frequency, then you choose your tuning system and your temperament, and then in certain places the sacred frequencies will show up. So, once again, there is no one scale where all the sacred frequencies are represented. It simply isn't possible. That's not how it works. So there is no one tuning that you can use and play all the magic frequencies. I'm sorry, I mean, we all wish it was so, but that's not how it works. It isn't that simple. However, there are tunings for all the magic frequencies, and they work like a charm, no worries. Okay, so let's look at the ratios and of course the frequencies. If we use Pythagorean tuning and we start with a note of A, 432 Hertz. The first note is a unison. The ratio is 1:1, and that of course is 432 Hertz. The next note, A sharp, is called an apotome. Its ratio is 2187 to 2048. And how you calculate this is that you simply take your root frequency, which in this case is 432. You multiply that by 2187, and then you divide that by 2048, which gives you the frequency for A sharp as 461.3203125 Hertz. Next one is B. It's a major whole tone. The ratio is 9:8. Again, you take 432 and you multiply it by 9 and you divide it by 8. This is 486 Hertz. This is a number we know, and like. The C is a minor third. The ratio is 32 to 27. And in this case, we get 512 Hertz. Another number we know and like. C sharp, ratio 81 to 64. This is a major third. And the frequency is 546.75 Hertz. D, the ratio is 4 to 3. This is the perfect fourth. And the frequency is 576 Hertz. This is an octave of 144. Next one is D sharp. The ratio is 729 to 512. This is what it's called a tritone. And the frequency is 615.09375 Hertz. Next note is an E. The ratio is 3 to 2. This is the perfect fifth. That is 648 Hertz. And then we have the F. The ratio is 6561 to 4096. This is called an augmented fifth. And the frequency is 691.98046875 Hertz. Next one is F sharp. The ratio is 27 to 16. This is called a major sixth. And the frequency is 729 Hertz. Then we have the G. The ratio is 16 to 9. It's a minor seventh. And the frequency is 768 Hertz. Then we have G sharp. Ratio 243 to 128. This is a major seventh. And the frequency is 820.125 Hertz. And then we have the octave. The ratio is 2 to 1, and it's 864 Hertz, of course. If you notice, the ratios in G sharp is actually sacred frequencies in themselves. 243 is a B. It's an octave of 486, which is a B in this particular tuning. 128 is an octave of 512, which is a C in this particular tuning. This is the thing that often happens when you start playing with these numbers and start calculating and experimenting, is that the same numbers repeat themselves under different circumstances, and the decimals have moved, but the numbers are the same, which I personally find very cool and very interesting. Let's look at some more examples. Say we start with a different frequency. Let's say we start with a C. And we say that C should be 256 Hertz. I'll explain in a later video exactly why. A C sharp would be 273.375 Hertz. A D would be 288 Hertz. So once again, it's an octave of 144. D sharp would be 303.4074074074. I don't know if I said that right, but anyway, you can see it. And E would be 324, which is the octave below 648. F would be 341.333333. F sharp would be 364.5 Hertz. G would be 384 Hertz. G sharp would be 410.0625 Hertz. A would be 432 Hertz, and A sharp would be 455.11111, and so on. And B 486, and the C, the octave of the C again, would be 512, of course. So as you can see, it's not exactly the same as the previous one, but it's pretty close, and many of the same numbers show up once again, and many of the sacred frequencies are represented. Let's do one more example. Let's start with D, 144 Hertz. D sharp will be 153.77343375. E would be 162, which is one octave below 324, 2 octaves below 648. F would be 170.66666, many sixes and a 7 at the end. F sharp would be 182.25. G would be 192. G sharp would be 205.03125. A would be 216, which is one octave below 432. A sharp would be 230.66015625. B 243. C 256. C sharp 273.375. D 288. So as you can see, depending on the root frequency, what note and what frequency you start at, the other notes change a little bit. But in all these three examples, several of the sacred frequencies show up. And this is a very harmonious tuning system. This is far more harmonious than equal temperament. I urge you to write these ratios down. I have explained how you calculate it, and experiment for yourself. Start with different frequencies. Take all the sacred frequencies that I've mentioned in my videos so far. You can especially check out the video called The Magic Frequencies, and start calculating and see what happens. And you will see that in every scale, some of the sacred frequencies show up, but not all of them. Because once again, there is not one scale where all the sacred frequencies are represented. It would not be harmonious. That's not how it works. Simple as that. Thank you for watching. Thank you for playing my music. If you want to know all of this right away and don't want to wait for me to get through all this video making, then you can go get my book. It's available on Amazon in all countries as a Kindle and as a paperback. If you like what I do here and you would like to support me, I really appreciate that. I have a Patreon page. You can also play my music in Spotify, iTunes, Amazon Music, YouTube, Google Music, Deezer, Bandcamp, SoundCloud. I am pretty much everywhere, and I really appreciate you listening and watching my work. I will link my website in the description of this video. If you click it, you will find links to absolutely everything. Once again, thank you for watching, and I'll see you in about a week.